right. Hello, I am Susan. I'm going to help you with this problem. So you are trying to find the equation of a hyperbola that has x orientation or horizontal orientation. And this is the general form. I wrote it on the board for that, for a horizontally oriented hyperbola. But even if they hadn't told us, I would have known that it was horizontal because the vertices are 2, 0 and negative 2, 0. And it goes to the point 4, 5 root 3, which is somewhere up here, 4, 5 root 3. And so we have to have a parabola that looks hyperbola that looks something like this. And so we know we're using this form. Okay, so we know also that the center is right in between the two vertices here at 0, 0. So that's super helpful because that means that the value of A is half that distance from between the vertices, or 2, the distance between the center and the vertex. So that is 2. So we know A is 2. So we don't know B and we don't know C. So let's write down, but we do know, again, the center is 0, 0. So we're going to write down x minus 0, because that's our center point. Our center point is HK. So x minus 0 squared over 2 squared minus y minus 0 squared over b squared, we don't know that, will equal 1. And I'm just going to do a little simplifying here and write x squared over 4, because x minus 0 is x, and I would square the 2 down below. And then y minus 0 is y, so that's going to be y squared over b squared is going to equal 1. So that looks a little bit better. We're not done yet, though, because we have to find b. But we're very happy because they gave us an x and a y that would work in our final equation. So this xy, we're going to put this in for the x temporarily, and we're going to solve for b, and then we'll go back and rewrite this equation right here with the b value that we find. So again, I'm going to substitute in the for x, I'm going to put in the 4, and then for the y, I'm going to put in the 5 root 3. So I go ahead and do that. So that's going to be 4, and then everything else is going to stay the same over here. So 4 squared over 4 minus, and then for y, I'm going to put in 5 root 3. Now this is a little tricky because I want to square all of y, and it's easy to leave that squared just next to the root 3, but it all gets squared, that 5. So we want to make sure we put a grouping symbol in, and then again over b squared, I don't know b, is equal to 1. And you can see here, oh, I have an equation that I'm going to be able to solve. It won't necessarily be easy, but I should be able to, because one equation and one unknown, that's solvable. So 4 squared is 16, so that's 16 over 4 minus, and then 5 root 3 squared. You could do this on your calculator, but it's a good idea just to practice. It's 5 root 3 times 5 root 3, and you can commute the 5s next to each other, so that's 25, and root 3 times root 3 is root 3 squared, and so root 3 squared is just 3, so that's going to be 75 over b squared equals 1. And then I'm going to just simplify that to 4 minus 75 over b squared, and just keep solving for b. So I'm going to take away 4 from both sides. Just going to speed up a little here so our timing works. That's a negative 3. And I've got a problem. I'm still, remember, trying to find this b value, and it's in the denominator. So I multiply both sides by b squared just to get it out of there and get it ready to solve. And that gives me negative 75 equals negative 3b squared. I divide both sides by -3. B squared equals 25. So B squared is 25. B is plus or minus 5, but remember we're trying to find B squared, and I know it's 25. So my equation, I can go back to and write x squared over 4, that's what I had before, minus y squared over b squared, which is 25, equals 1. And that's my answer. I can always check by putting in this point, or I could graph it and make sure that point is on it, that 4 or 5 root 3, but this would be the answer. All right, I hope that helps. Have a great day. Bye.